Hello there, and welcome to this video, which we are going to be looking at OCR GCSE Computing 2.14 representation of data, and we're going to be looking specifically at image representation. What OCR say that you need to know is you need to be able to explain the representation of an image as a series of pixels represented in binary, explain the need for metadata to be included in the file, such as height, width and colour depth, and discuss the effect of colour depth and resolution on the size of an image file. So here we are, we're going to be looking at the representation of an image as a series of pixels represented in binary. First thing to remember is that all images are made up of pixels, tiny little squares. If you put your face very close to your screen, you can see it's made up of little blocks. One block is one pixel. You can see here on this image we've got the letter H, and we've created a grid here which is going to be our series of pixels, but we just made them a lot bigger. If we're going to be looking at this, because this is a nice simple image, we can make this up with binary quite easily, with the white squares being equal to 0 and 1 is being represented for the black squares. So the top row of this would be equal to 0, 0, 0, 0, 0. The second row would be 0, 1, 0, 1, 0. The third row would be 0, 1, 1, 1, 0. The fourth row 0, 1, 0, 1, 0, and then the fifth row another group of zeros. One thing to also remember is that, for example, the amount of colours that you can be using. So for example, with 1 bit we can have white or we can have black, nothing in between. For 2 bits we're then doubling the amount that we can be using. So for example, 0, 0 could be white, 0, 1 blue, 1, 0 red, 1, 1 would be black. And again, the more bits that you have, the more colours are available to you. Another thing to remember is the resolution of the image, and the resolution isn't the resolution of the monitor, it's the resolution of the actual image you've created, and it's measured in pixels. So for example, a resolution of 1024 by 798 pixels has 1024 multiplied by 798 pixels, which I've done the math for you, is 817,152 pixels. The metadata is data about data, so it gives you lots and lots of information. So for example, what OCR say that you need to know is talking about height and width, which lets you know the size of the image, and that's the resolution of the image, so it tells you how large the actual image is. The colour depth lets you know about what colours are being used and the depth of them, and that's normally measured in bits. The more depth that you have, the more colours which are available to you. This means, however, that the file size will be a hell of a lot larger than one which has got a smaller colour depth, which we now come on to here. The colour depth allows you to be able to say how vivid, how intense the image looks. The more lifelike, the more realistic, the more colours which are needed. If you think about the human eye, it can distinguish millions and millions and millions of different colours, which are then in turn understood by your brain so you can know what's being seen. Exactly the same concept with a PC and an image. The image, the more colours that are being used, the higher quality of image it is. If you think about, for example, the Steam logo, it uses a lot of different shades of light blue from the bottom to dark blue at the top, different shades of white, different shades of grey. So the more colours which are being used, there's more data, there's more ones and zeros being used, which means the larger the file size. Similarly, if it's a low colour depth image, it's got less colours, less data, less file size. The resolution is the size of the image, and again remember that it's being measured in pixels, and again the larger the resolution, the larger the image. The larger the image, the more data, larger file size. I hope this has been helpful for you. Feel free to like, comment and subscribe, and I'll see you in another video.